Alright, so we're going to start from trig. Okay, so we're going to stop on functions and graphs because I need to get this done so that the extension students, after you've done your permutation combinations, you'll be able to do extension trig after covered everything in trig in mathematics. Okay, now most of it you have done, so you've all should have done right angled triangles, you've all should have done angles of elevation and depression, you've all have done problem solving involving right angled triangles. Yeah? Have you done non-right angled triangles?
I don't think we have.
Using sine rule, cosine rule, c squared equals a squared plus b squared plus 2ab cos c? Really? Bearings? Have you done bearings?
Yes.
Good. Well, you're going to have all that and a few new things as well. Alright, so it's page 41 on the 8. Alright. Alright, now I believe I've done trig with you in year 9 when I took the class again, and you've done it in year 10. Okay, so most of this first section, most of it is stuff you've already done before. Alright, so from stage 5 work, we should be familiar with finding unknown sides at angles in right angled triangles. Okay, if you've got a right angled triangle, okay, you've got two angles, you're typically going to be theta. Okay, the other one could be alpha, or whatever we want to notate it. Okay, so we should all know the following. So sine theta is opposite over hypotenuse. Okay, we should all know how to label those three sides. Yes? Alright, let's do a right angle triangle. Okay, so make theta. So the first thing we do, from the right angle, point to the opposite side, just like in Pythagoras' theorem, that is the hypotenuse. Okay, then from the marked angle inside the diagram to the opposite side, over opposite, and the side that has the two angles on it, or the leftover side, is the adjacent side. Okay, so sine, cos and tan theta are all based on ratios. Okay, that is why we have those three things. Okay, so we have cos theta, which is the adjacent side over the hypotenuse side. And we have tan theta, which is the opposite side over the adjacent side. Okay, you shouldn't have already been covered that in the last couple of years as well. Okay, so different ways you can remember that. Okay, if I taught you, I'm sure I would have done this. Soccatella. Okay. Soccatella. Alright, so the first letter gives the start of the ratio. The middle letter is the numerator of the fraction, and the denominator, the third letter of each group of three letters is the denominator. Okay. Some old hag can't always handle their own alcohol. Alright, there's another way people remember it. Okay, and lots of different things I've heard over the years, but they're the two that I try and teach. Okay, so whatever it takes you to remember it, takes you to remember it. Alright, so now we've got some right angle triangle problems. So, examples A. Right, so you can draw on our diagram on the paper. We've got a right angle triangle. We have 5.2 metres, 28 degrees, and we have x metres at the top. So find the value of the pronominal, correct to 2 decimal places, or correct to the nearest minute. Okay? So typically when you do these sort of things, there are 4 things you need to do. Okay? So number 1, identify your three sides. Okay? So from the right angle, arrow pointing to the opposite side, so hypotenuse. Then from the marked angle, arrow pointing to the opposite side is over opposite, and the leftover side gets the capital A, adjacent. Step 1. Okay. Step 2, you need to determine the correct formula. Okay, based on what information you have and where the variable is. All right. So I know how long the opposite side is. All right. So I'm given the length. I am going to use that. Okay. there is no number or there's no letter on the hypotenuse. Okay, so for this specific question, I am not going to use that one. Okay, and the variable is on the adjacent. Okay, so which of the three formulas uses O and A? Okay. Okay, so 10. Right, so step 2, write that formula once you determine it. Okay, number 3, substitution. So 10 of 28, so theta is the angle inside the triangle. Which of those two sides have been referenced to? The opposite is 5.2 and the adjacent is x. Okay, so we're done basic arithmetic, we've led into algebra, we've done algebra, we've led into equation, we have done equation, which has led into zones and geometry work, and it's also leading to our trig. Okay, so we need x as subject. When x is on the bottom, okay, you need to swap. Alright, when the variable is on the bottom, we swap. So x is going to be 5.2 over 10 of 28 degrees. Okay, equals. Right, before we go to calculators, you need to have on your calculator screen, okay, up the very, very top, the little light, there should be a little d there, okay, for degree. Alright, there are two others you could possibly have. You could have R, which we'll look at in the HSC course, okay, radiant measure, okay, and G is another one which basically refers to the gradient, okay, but we're not going to use that at all. Okay, so everyone needs to ensure that there is a little d there. If that d is not there, that means all your answers are not going to be correct, okay, because it's different measures. Alright, so 5.2 over 10, 28, after you got that d up the top on the display, and we want that correct to 2 decimal places, please. Answer? 9. Do you agree? 2 decimal places?
Sorry to interrupt. Let's need to get this out for a casual teacher.
Ooh, we need to get that camera moved. Can you put that camera on top of that box next to it? And then rotate it this way. Yep, a bit more. Yep. Okay, do we agree on the answer? That's correctly 2 decimal places. And the other thing you need, because it's a distance, you also need the units. But however, it's already given to you in the diagram. Okay, so you don't need it now.
Snow, do you need this?
That's mine. Alright, B. Okay, you don't need to redraw these diagrams, you can just write over your notes. That's why you got them. Alright, so 72 degrees, 25 minutes. We have X millimetres. Okay, so that means when I answer, I don't need to have the units in my answer because it's already there in the question. Okay, and 84 millimetres. Okay, so we need to find that X on the bottom. So 4 steps. Number 1, label your 3 sides in reference to the angle in there. Number 2, determine the correct ratio. Number 3, substitute into that ratio. Number 4, solve. Okay, right angle, opposite side, hypotenuse, marked angle, opposite side, O, and the leftover side gets an A. Okay, so the variables on the hypotenuse, I need to use that as part of my formula. Okay, I know how long the opposite side is, okay, because I'm told, and there's no information at all on the adjacent. Alright, so for every pretty much 95% of your right angle triangles will be this sort of manner, okay? Alright, so which formula uses O and H? And it's pronounced sine, it is not sin. Alright, sine theta is equal to O for H. Okay, so that's step 2 done. Step 3, substitute. So you've done substitution algebra in your equation. So sine of 72 degrees, 25 minutes. So just like on a clock, there's 60 minutes in 1 hour. So there's each 1 degree is broken up into 60 equal intervals. Okay? And then there's seconds as well. We work on the same principle. 1 minute is equal to 60 seconds. Okay? Right, so O is 84. And H is X. Alright, so again, the variable is on the bottom. Okay, I'll take a different example. But, okay, so when the variable is on the bottom, alright, so what we need to do is multiply both sides by x to remove the denominator. So that's what we've done in the equation. And then we still have x times sine 72 degrees, 25 minutes. So we then have to divide both sides by that. And that's why I say we just swap it. Okay? So we're not doing equations, you're doing applications of equations now. So, x is going to be 84 over sine of 72 degrees, 25 minutes. So, when you put it in the calculator, you've got that something that looks like this button. You need to push that twice, okay? At 72 degrees, 25, and push that button again, and it'll give you the same mark, but it will be referencing minutes, okay? For this question here, you didn't have to put degree over here, okay? Because by default, it will recognise that you just put the one thing in, therefore it will treat it as a degree. Okay, so you will need to push this twice. Okay, alright. 2 decimal places.
1, 0. 1, 2, 0.
2 zeros.
1, 5.
1 5.
1.
It's 1 1 2.
1, 2.
One,
It's
two.
1, 2.
It's 1 2.
Oh, yeah, it's 1, 2.
Jesus, guys.
Rounding.
Rounding skills.
Rounding skills, way back. 1.
Oh my god.
Right, so again, I don't need to put my units here, okay, because it's already there in the diagram. If it wasn't there in the diagram, you would need to include it in units, okay? Right, any questions so far? Everyone should be fairly comfortable doing this sort of stuff, am I correct? Anyone not sort of getting the hang of it? Right, see. Okay, so we've got the variable inside the triangle, so we're referencing an angle now. Alright, so we need to find the side of the angle. Okay, so the first 3 steps are exactly the same. Just that solve step. There's 3 different things you can do depending on where the variable is. Okay, so we've seen one example, we'll see another one now. Alright, here's a little trick for you now. In your sine and cos ratios, okay, you should always have a proper fraction. Okay, you should never have a fraction that's equivalent to 1 or greater. Okay, in your tan you can. Okay, you can have an improper fraction, but you always have to have a proper fraction for these ones. Okay, because the hypotenuse is the bottom of both sine and cos, and that's of course referencing our longest side in our right angle triangle. Okay, so we need to make sure that if we recognise that we don't have what we expect, then we need to go back and fix it up. Okay, right, so to get the value for theta, okay, so we'd see an example where the variable's on the bottom, you swap. When you have theta, okay, so what you need to do is bring that over to the other side and become a cos inverse. Okay, cos inverse, so cos with a index of -1, and we refer to that as the inverse. And in the HSC Extension 1 course, Alright, we'll be doing a lot more work on that concept there. A lot. Alright, so on your calculator, so you need to push shift. That's shift, okay, and then the function you want, sine cos of 10 to get the inverse, and then put it in the fraction. Okay, so we have that to the nearest minute. So after you put it in, you most likely get a decimal. Okay, if you push the degree button again, it'll convert from the decimal to a degree.
45 degrees and 34 minutes.
45, 34. Right, theta 45 degree, 34 minute. It said 22 seconds. Okay, so you need to look at the second and treating it like a round of clock. So the 22 second is still closer to the start of the minute than the end of the minute. Okay, so to the nearest minute, just like a time, that'll be correct. Alright, so if it was 30 or further, you would have to add 1 to the minute. Alright. Question? Alright, so with the note there as well, your calculator should be set to D mode for degree. And again, there's 60 minutes in a degree, 60 seconds in a minute. So when rounding angles to the nearest degree or minute, we either use the 30 minutes or the 30 seconds, depending on what we're rounding for. Alright, use the halfway point to round up or down. So don't do 50, because that's not the halfway point for your minute or second. Alright, so that takes care of 3 exercises already. Alright, I'm going to start the next section and then I'll give you some time at the end. Has anyone got any questions ready for their assessment? Any direct questions you know you need to ask? Nope. Alright, so let's look at the next one. So we're looking at a new thing now, the reciprocal trig ratio. You haven't heard of cosec, sec or cot before? No? Alright, so it's new for everyone. Okay, so there are 3 reciprocal trig ratios. First one is called cosec, which is short for cosecant. Okay, so cosec of theta is equivalent to 1 over sine of theta. Okay, so reciprocal is when we flip a fraction. Okay, so like when you're dividing by a fraction, you multiply by the reciprocal. What you're doing, you're flipping it over. Okay, so for sine theta, it was opposite over hypotenuse. So for cosec theta, it's going to be hypotenuse over opposite. Okay. Alright, next one is called sec theta, and sec is short for secant. So extension 1 students, you know what a secant is. A mathematics student, a secant is a line that cuts the circle at 2 places. Okay. Alright, so if I do a circle and draw a line, 2 places it intersects, that's the secant. Okay, so sec theta is equal to 1 over cos of theta. Okay, cos of theta was adjacent over the hypotenuse, so we flip that over and we get the hypotenuse over the adjacent. Okay, last one is cot theta. Cot is short for cotangent. Okay, which is 1 over tan of theta. Okay, tan theta is opposite over adjacent, so cot theta is going to be adjacent over opposite. But how are you going to remember these? Nice and easy, okay? You take the third letter of each of those, so cosec, sec and cot. Take the third letter, okay? That gives you what you need here, okay? S for sine, C for cos, E for tan. Okay? So the third letter of each of those, cosec, cot, cosec, sec and cot will give you what you need from the bottom of the fraction. Right. Right. Example, so from the diagram, D C D A 5 meters 13 meters. Okay. So from the diagram, write down the exact fraction equivalent to. So we've got cosec of A. Okay, so that's referencing the angle up here. Alright, so what you need to do is one of two things. One, well, both ways you have to identify this with a sign, okay, because the third letter is S, so we're relating to sign. Alright, so 1 over sine theta means you flip that fraction that sine theta is equal to. Okay, so sine theta is equal to O over H. Cosec of theta is going to be H over O. Alright, so from A, so this is always going to be the hypotenuse. From A, that's going to be the opposite, and this side is going to be the adjacent. Referencing from A. Right, so we know what H is, however, we don't know what O is. Right, so we need to actually work out the value of O.
Pythagoras.
Pythagoras theorem. Right, can anyone here tell me what the value is without doing Pythagoras theorem? Right. 5, what, and 13 the Pythagorean triad.
169. So,
What?
what's 169 minus?
Do you know about Pythagorean triad? Pythagorean triad is 3 whole numbers that make the right angle triangle. Okay? Now, there is a set of 3 numbers, 5 and 13, okay, that make a Pythagorean triad.
12.
Right? It is 12. Right, so we need to do first O squared, which equals to H squared, take away A squared. So 13 squared take away 5 squared, 169 take away 25, which is 144. Now your working doesn't need to be that elaborate. Alright, I'm just making a point. Alright, so O is equal to the square root, just a positive square root, because we are specifying specifically distant. However, you're used to, when you're using Pythagoras theorem, you're always taking the positive square root. Okay, which is 12. So that side is going to be 12 metres. So there's a group of 3 whole numbers, 5, 12, 13, that makes a Pythagorean triad. Okay, if you double them, okay, so 10, 24, 26, that's another Pythagorean triad. Okay, if you multiply each of these guys by 10, 50, 120, 130, that's another Pythagorean triad. Okay, there's an infinite number of Pythagorean triads. Alright, so therefore cosec of A is just h over O. We knew what h was, so 13, and O is 12. Okay, that's all you need to do. Just state the fraction that it's equal to. Sec of A. Okay, so now we have our three sides. Alright, so now it's just a matter of identifying the formula and then writing the correct fraction. Alright, so the third letter in sec is a C, so it's the inverse of cos. Alright, so cos is normally adjacent over hypotenuse. When you flip that over, it's going to be hypotenuse over adjacent. Okay, so 13 over 5. Okay, so your cosec and your sec are always going to be improper fractions. Okay, because you're flipping over a proper fraction for your sine and cos. Okay, but your cot can still be either. Okay, because tan can still be either. Alright, and cot A. So again, the third letter gives you the ratio. There was a tan. So the inverse of tan, the reciprocal of tan. So tan is normally opposite over adjacent. So it's going to be adjacent over opposite. Okay, again, we've got 5 over 12. Okay, in this case proper, but we could still have an improper depending on the variables there. Right, E. Alright, so now we've got cot B, sec of B, and cosec of B. Alright, so now we're referencing the other angle. So this one now be done in a red pen. So, relating to this angle here, this is still the hypotenuse. So the side opposite the right angle is always the hypotenuse. And then referencing that side, that is the opposite. So the adjacent now becomes the opposite when you're doing the opposite angle. And the opposite then becomes the adjacent. Okay? Alright, so first cot of beta. Okay, last three I'll do today, because then it'll give me a starting point for Tuesday. Right, so cot of beta. Right, so the third letter, tan. Okay, the reciprocal of tan. Tan is normally adjacent over opposite over adjacent. So cot is going to be adjacent over opposite. Now it's the red one. Okay, so adjacent is now 12, and the opposite is 5. Alright. Right, sec of beta. Alright, so third letter, C, for cos. So cos is normally adjacent over hypotenuse. So sec is going to be hypotenuse over adjacent. Okay, reading the red because that's what's referencing the angle at B. It's going to be 13 and 12. Okay, last one, cosec. Okay, so the third letter, not the last letter, because we've got a 5-letter word there. So S for sine. So take the reciprocal of sine. So it's normally opposite over hypotenuse of sine. Take the reciprocal is going to be hypotenuse over opposite for reference to the angle B. So it's going to be O for 5 and H is 13. So cosec okay, which is an improper fraction, is what we're expecting. Okay, so when you flip a proper fraction, you will get an improper fraction. Okay, so your sec and cosec should all be improper fraction. Okay, I will stop there. That'll give me a good starting point for next lesson. Okay, so Monday's your assessment. Okay, and then we'll carry on to trig on Tuesday.
What time does it start then?
Okay.
What time does it
You have like 20 minutes.
Right, so we've got about 20 minutes. If you've got any questions, ask them now. Otherwise, some people are looking like they're having an early night's sleep tonight,
Yep.
myself included.
Why?
Why?
A screaming baby this morning.
Aww. No. We can't prove anything.